I went in, they know my name. Don't know how I feel like I got some feelings that I can't explain. Mm, 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 mm. Don't know why I feel like I got some feelings that I can't explain. Okay, what should I do? Yo, let's go to need code IO. This is like 100% now. Come on, put this here. Man, put this. Oh, God. Yep. If big is the principal, I hope my people can call and read. Put this right here. Okay. Keep the streak alive, bro. I'm not trying to kill the streak. I think that's the only reason why I'm doing this, because somehow it's about the streak. And another thing, I just think the live streams keep me more consistent and accountable as well, because I get to show up for you guys every single day, my brothers. You feel what I'm saying? And yeah, partly let me just make sure I can read the chat somewhere here. Okay. Yo, boys, go ahead and like the live, bro. Let's start with today's. I don't know if I should start with like DSA, or I should first solve the problem that we are facing. I think we should first solve the auth 2 problem, then we can do DSA. I don't know. I don't know. What do you think, man? Lost Pocket, what's good, my brother? How you doing, bro? By the way, last time I checked, you are from Nigeria, right? Are you Niger? Are you my brother from Africa? All right. We have, I think, we solved daily problem, daily temperatures yesterday. We also solved mean stock problem. We solved reverse Polish notation. Not really. South Sudan. Oh, you're from South Sudan. Okay, that's nice. You're also a programmer, right? Hey, from India. What was that name? Krantik. I think. Wait, you were there yesterday on the stream. Kumara. I know I've butchered your name, bro. I'm really, really sorry, bro. I apologize, man. I'm so slow when it comes to pronunciations. Okay, calf lead problem. Should we do first the DSA, or we should just jump straight into solving the auth 2 problem? Yeah, I'm thinking we should just start with DSA. I think that would do it, right? I think DSA would do it. All right, so this is yeah. How is India, by the way, bro? How is India? How's India, man? Oh, we should start with DSA first. Okay. Yeah, I really need to get an internship, bro. Like I've been looking at let me first open this. What's the name of this? I think it's LinkedIn, right? I've been looking at LinkedIn, bro. I really wanted to get an internship, man. Uh let's have a look. I think we need to go to jobs and I need to search for internship. Yeah, it's all good here. All right, cool. Thank you so much, my brother, for tapping in. Soon as you join the live, bro, like the live. I'm almost losing my voice, as you guys can see, bro. Because I normally be so I normally have so much energy on stream, but yeah, you guys have to bear with me, bro. I'm just gonna put Java. Uh yeah, I think I'm just gonna put Java. And city, I could say, oh, let's just say internship, right? Java internship. And I don't know, the city could be anywhere. Maybe we'll look at UK. I think UK will make more sense. Or United Kingdom. United Kingdom. Okay, let's have a look. Of recent, bro, I've been scouting like UK. I really want to work in UK or just work remotely, but get paid in euros or I think it's Great Britain or British pound or something, GBP, something like that. We have a Java developer remote job. Okay, let's first see what they need. All right, Java developer remote. Look, 5 hours ago, bro, only 41 applicants, and this is now promoted by Hira. So okay, let's have a look at what they need. They need 5 years UK residency required. What? How can the title say remote? How can the title just literally say remote? And then they say they need 5 year residency in UK. I don't understand it, but it's okay. They need 2 to 3 years of development experience, system administration, experience with J2E applications, JBoss, Jenkins. Yeah. This some complex stuff. It's okay, bro. Let's look at the intern here. This was 3 weeks ago. Let's look at what they need. Uh well, I really don't think this, bro. Is it possible to get a job on LinkedIn? Is it like possible to really get an internship or whatsoever on LinkedIn? Because they're asking for like 2 years. I don't have none of that shit, bro. It's okay. Let's just continue with our DSA problem. Now we have the n cars at given miles away from the starting mile zero, traveling to reach the mile target. If you are given two integer arrays, position and speed, both of length n, where position I is the starting mile of the ith car and speed I is the speed of the ith car in miles per hour. It's very difficult to get a job on LinkedIn. I don't know, bro. Sometimes it's just like maybe we are just coding for no reason, bro. Because are there jobs, bro? Are there jobs guaranteed? Yeah, I highly doubt, man. It's all good though. Damn, this stuff is so dusty. Whatever. Okay. They need a car. I mean, a car cannot pass another car, but it can catch up and then travel next to it at the speed of the slowest car. Oh God. A car fleet is a single car or a group of cars traveling next to each other. The speed of the car fleet is minimum speed of any car in the fleet. I'm starting to think this problem is a stuck problem, right? And it's true, we are solving stuck problems. Why is it medium? It kind of looks hard. If I don't know, kind of looks hard to me. If a car catches up to a car fleet at the mile target T, it will still be considered as part of the fleet. Return the number of car fleets that will arrive at the destination. Okay, so this one, it looks like we have to just return the position. Wait, the number of cars that will arrive at the destination. So let's look at the problem statement and we try to use this. Just reduce it. Okay, we try to use what we have here to try to solve the problem. So assuming we have a target 100 and then we have positions, let me just open Excalibur so I can visualize it better. Okay, fine, not bad. Excalibur, I'm just gonna try to visualize this problem. We have a position. Where is it at? Where is it at? Okay, we have, I think I saw 100 somewhere. Oh, this was the, okay, fine. Let's look at position 12. And we have target 12 and positions will be 10, 8, 0, 5, 3. So we're gonna have positions array, right? This will be positions, and within the positions, bro, why is this mouse just not working, bro? Yep, we're gonna have positions like this. How can I reduce this? Okay, fine. Well, we're going to have this. I think to have, how do we get a sharp? Yeah. Okay, so we use shift. All right, we have that. Let's assume we have the target as 12, but positions we have 10, 8, 0, 5, 3. Let's just copy this with the entire, matter of fact, let's copy the entire thing with its output, and then we just press it here. Okay. And let's increase this a little bit, and then we try to visualize it and see what's going to happen. So given we have a target to reach, which is 12, and the positions are 10, 8, 0, 5, and 3. So we have 10, 10, 8, 0, 5, and 3. So the speed is also going to be 2, 4, 1, 1, 3. Now, what are these ones, right? Um, what are these ones? I don't know if you guys can see that this is 2, but it's okay. So if the output is 3, that means the position we are considering, if we start from I here, from here is I, and then we look at its speed is 2. We could say also I mean S for speed. We could say P for position, right? P is equals to 0 index, and here's also 0 index, but the value is 10. Here the value is 2. And then the next one will be 8 on 1 with the value of 1 as well. I mean, this is 8, the value of 8, 1 position, and then 8 as the value, and corresponding to its speed is 4 on 1, right? So we have 1, 4, 1, 8. Now let's look at another one. 0. Obviously, if we use the speed here is going to be 0. And then here we have 5, and its speed here is 1. So we have 5, and here we have 1. And then 3 and 3. So in order for us to get this target position 12, right? Any car that will move at the same speed, the same speed they will make a car fleet, right? If a car catches up to a car fleet at the mile target, it will still be considered as part of the fleet. So a car fleet is a single car or a group of cars driving next to each other. The speed of the car fleet is a minimum speed of any car in the fleet. So how do we get the minimum speed of any car in the fleet? That's the only problem we need to now target, right? So how did we get the output of 3 here is what I want to find out. So we look at target 12. That means we are picking 10 plus 2 is 12, right? And then 8 plus 4 is also 12. 0 plus 1 is going to be 0. I mean, it could be 1. And then 5 plus 1 here is going to be 6. And then 3 plus 3 is going to be 6 as well. So the ones that are running at the speed of 12 and 12, they are all going to be in one fleet, right? If I'm not mistaken, this is going to be one fleet, right? This is car 1, car 2, they'll all be in one fleet since they're running at 12 miles per hour, right? Or whatever, 12 miles per hour. And also 6 and 6 is also going to be one fleet. Oh God, I just don't know how I can interpret this problem, but let's just copy this entire problem and then we can let AI break it down for us, okay? I think I'm gonna open Gemini. I'm not gonna get the solution, don't worry, okay? I just want to get like the entire problem set broken down for me. Okay, so let's say break down this entire problem set and let me know what is required. Don't give me the code. Give me the code. Just reason with me so I can be able to solve the problem. Don't give the actual code. All right, let's see if we are going to get anything closer. So this is a classic bottleneck problem. The core challenge is figuring out how cars interact when they are restricted by the cars in front of them. Since um, since cars cannot pass each other, a faster car coming from behind will eventually be forced to slow down to the speed of the slower car ahead. Good, good. Now we are getting some concepts, right? Here's the logical breakdown of how to approach lead code this car flip problem. Um, the core realization, look from left to right, look from right to left. In this problem, the car closest to the target is the leader. The door is open little. Hmm? It's almost raining, right? Hmm? Mhm. I couldn't find the other good milk. I just brought the dust milk. Yeah, dust milk. There's sugar already, so dust milk and biscuits. You should have made them like this, kid. Even me, I need mine to chop. You understand? All right. Okay, in this problem, the closest to the target is the leader of any potential fleet behind it. So if a car behind a leader is faster, it will eventually catch up and form a fleet. If a car behind a leader is slower, it can never catch up and it will become the leader of its own new fleet. All right. So that means we are creating a new fleet from this one. This one will be their own fleet. So this will be considered one. But this is also one. So how is that possible? God. Okay. If a car, if a car, right, behind a leader is faster, it will eventually catch up and form a fleet. That is correct. If a car behind a leader is slower, it can never catch up and it will become the leader of its own new fleet. Because of this, the first thing you should do is sort the cars by their starting position in descending order. So sorting is also part of what we need to do. Because of this, the first thing you should do is sort the cars by their starting position in descending order from the closest to the target to the farthest away. So how should we attempt this? The first thing you should do is sort the cars by their starting position in descending order from the closest to the target to the farthest away. All right, let me try to understand that. Mm. So if we look at this, we're going to have target 12, position 108053. Okay. Uh, because of this, the first thing you should do is sort the cars by their starting position. So we should sort them by their starting position, which is here. Okay. And in descending order from the closest to the target to the farthest away. Okay. So given the target, right, we need to, if the target is 12, we can sort this entire fleet out. And then we are going to get, if we sort 108053, starting from closest to the target to the farthest away. So 0 is so far from 12, but 10 is closer. So we're gonna get 10, 8, and 5, 3, and 0. This is when we sort out. right? Me, I need to really, I need to understand this entire problem, boys. Like, trust me, I'm going to pick it. I'm going to get it. Don't worry. Just wait. I'm going to understand this entire problem. And I apologize if we are being boring, my boys. My voice, I can't speak louder than this. For the last 2 days, I've been screaming, shouting, and my voice, I can't even like. I'm about to lose my voice. But nonetheless, we gotta keep grinding. So if the target is 12 and the positions are these ones, so in order to get the cars that are farthest from each other or the closest to the target, we need to go ahead and let me say we are going to sort. Let's say sort from, I think, from closest to farthest. Is that farthest to the target? Okay, that's what we're gonna do now. Let's see how we are going to approach that. We're going to pick this entire position and we shall sort out this input, right? Let's say the target is 12. The numbers that we need will be 10, 8, 5. 0 will be the last. So let's put 0 here. 0, this will be 3, and this will be 5. So that's how we are sorting them now. We need to sort by position. That is okay. Then what else? The metric that matters, time to destination. The speed and position alone I had to compare directly over time. The equalizer here is time. To reach the target, a car at position I with speed needs target minus position divided by speed. Okay, so at this point, I think we're doing some physics here, bro. Hold on, let me see if we're doing some physics. What is time? If we look at this triangle for physics, right? If I remember my physics very well, we had a triangle like I mean something like this, right, in physics, and then we had I think it's gonna be somewhere like this. Okay, I don't know if that's gonna be okay, but this is not. This is not accurate. We're gonna have something like this, right? Oh God. Okay. Wait. Just give me a sec, boys. Okay, give me a sec. Let me cook. Let me cook. Okay. Yep, we're gonna have this whatsoever this is. We're going to have. Let's say if we put speed here, then we're going to have time and distance, right? I think so. Speed is equals to no distance equals to speed times time, right? So that means we have to put distance first. Distance here, and then we're going to have S and we're going to have T. So in order for us to achieve, let me put this here, and let me say, in order to get a speed, we have to get, in order to get distance is equals to speed times time. Well, it's raining, boys. I don't know if you guys want to continue, if you guys want to listen to the rain sound. It's crazy. So, do you guys want to hear it? I can put this on standard. You guys can tell it's raining like crazy. Okay. So, in order to get this, I know it's a little bit noisy, but just bear with me. Okay. Now, let's look at in order to get distance, right? We have distance equals to speed times time, and then in order to get a speed, we're going to have to divide this time both sides. So we're going to get distance divided by time. Distance over time, right? I think something like this. Distance divided by time. Okay, and then in order to get time, if I remember my physics well, we have to divide distance divided by speed. All right, so at this point we need to get the speed, right? Return the number of car fleets that will arrive at the destination. But given what we need here, we need to reach the target. A car at position I with speed needs Time. So here we need actually time. We need to look at time because we are given a speed and position, which is this position. In order to get distance, we are going to say target minus position. Wait, wait. Distance is the target? No, 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 no. The difference between the current position and the target will be the distance you have to travel with respect to time. I think that is it. So the target minus the position divided by speed. So that's how we are going to crack down this entire distance. So if we want to look at only distance, I mean time, we're going to say time is equal to distance divided by speed. But here for us, the distance is now going to be the target, which is the position. I mean the target, which is the place we want to travel to, right? And we subtract the position, the current position that we are standing at. That is going to give us the time that we need, right? Okay, let's continue moving. So reasoning through the fleet logic. Once you have the car sorted by position closest to the target first, you've calculated the arrival time, you can compare them. Car A, leader, takes 3 hours to arrive. Target minus position divided by speed. Is it not what I had here? I think target minus position divided by speed. Yes, my boy. Yes. And this is, oh Lord, Brian. I don't know if I'm just throwing a tantrum here, but I usually just be happy. I feel happy whenever I'm starting to understand. I don't know if it's just me. Should I leave the rain sounds, boys, or just isolate it? Which one is better? Should I isolate it or leave the rain sounds? Which one is better? Let me know. Let me know, brothers. Yeah, let me know. Like the life, bro. As soon as you join the stream, like the life. You feel me? Support your brother. Let's get it. All right. So let's have a look at this. Target minus position divided by speed. Oh, this is better? Okay, okay. No problem. No problem. Thank you. Okay, so now we have time is equal to target minus position divided by speed. That is now our distance in general, right? The distance we have to travel. We need to look at the end or the final destination, which is the target, minus the current position that we are in. It will give us the distance that we need. If we divide it by the speed at which we are running, that means we are getting the current the time spent by every car. And then the first car, let's say if the first car arrives at like 3 hours, that's going to be a leader, right? And then the car behind will now take 2 hours to arrive if there are no traffic. Wait, I'm confused. Behind A. How can car A take 3 hours and then car B takes less time? Does it make sense? How will this leader be a leader if it's going to take more time? That means it's behind, right? Logic, since car B is behind car A but would arrive sooner, it must hit car A before the target. It becomes part of car A's fleet. Its arrival time is now effectively 3 hours because it can't pass. So how is it taking 2 hours then? Okay, car C behind B takes 5 hours to arrive. Since car C takes longer than the fleet in front of it, 3 hours, it will never catch up. It starts a new fleet. God, I don't know. Let's just take it step by step, my boys. All right. So let's try to see if we can figure out first how we can sort the entire position. All right. Let's first sort the position, and then what will happen with the speed now? 241. Yeah, I'm even confused. I can't lie, bro. I'm too confused actually. I don't even know how that is possible, bro. Hmm? Yeah. To Google Locator, okay? So that it will not have anything. So let's see. Target 12, position 10, 8, 0, 5, 3. So how are we doing it? You get it. If they did not confuse me here, right? I was understanding until this part. If this one came in 3 hours, how is this one taking 2 hours to arrive? If the one would drop. What? Okay, step-by-step strategy. Pair and sort. Combine the position and speed arrays in two pairs and sort them based on position in descending order. Pair and sort. Merge sort. Is that merge sort? Combine the position and speed. Speed arrays in two pairs and sort them based on position in descending order. So we need to get this 10 and 2, right? 8 and 4, 0 and 1. But if we have to use, if we have to sort it like this, right? Let me take this. If we have to sort it like this, if we have to sort it as position, and then we come and say, okay, this is going to be 5. This is actually 3. This is 5, and this is 0. But do we have to also sort the speed? I think we have to sort the speed, right? Do we have to sort the speed too? Or we only sort the positions? I don't know. So pair, combine the position and speed arrays into pairs and sort them based on position in descending order. Okay. Okay. Based on position. Will it make sense? Okay. Let's try to put 4, 2, here 3, 2, 1, 1. So that is that, and then we pair them. We're gonna have 10 and 4, 8 and 3, 5 and 1, 3 and 1, 0 and 1. Now let me try to combine them and see. Combine. We're going to have 10, 10 and 4. Okay, then 8 and 8 and 3. 5 and 2. Okay, 3 and 1. 0 and 1. So let's see if I'm breaking down this entire problem properly, right? Let's see. Okay, so now we have the pairs. We have 10 and 4, 8 and 3, 5 and 2, 3 and 1, 0 and 1. So if we hit the target, if the target is 12, target is equals to 12. Then how are we going to reach from 10 to this? Let's try to add 10 plus 4, it is 14. But this is position and speed. Okay. So in order for us to get the time taken, right? Let's now try to get the time taken. So time taken is equals to, now the time taken, we shall have to do some calculation. Let me open calculator. Right? I'm going to use this. And then let's start with the target. The position is 10. Matter of fact, the target is 12 minus the position, which is 10. We're going to get 2 divided by the speed, right? Which is 4. Then we're going to get 0.5. It doesn't make sense, right? Okay, let's say 0.5. Let's say this is gonna be 0.5, 0. Huh? After? The what? Bro, what do you mean after? Is a question ready? You finish yours, then you make mine. Or if you could make it now, there's no problem. I don't mind. Yes, I'm listening. Why don't you make it in the other blue plate? You just break them first. This one, why is it so thick like this? That's okay. And how many pieces did you make? You cannot take a delivery. Sorry, you said what? Daddy? No, Mama is my brother. I'm trying to mess up with him. You? Sut kar raha tha. That was you? You boy. Bro, you just leave. I'll make mine. For real. It's okay. You enjoy yours. Yeah, so it is what it is. Mhm. All right, let me close this off. Bro, I can't believe the calculator cannot go to the left. What? Come on, bro. Come on. What kind of design flaws these apples doing? Like I cannot goddamn take this to the left. This is stupid, bro. What? Is this apple or is this? Let me try to quit this. It can be apple, bro. Yeah, stupid. Calm down, bro. All right. So let's see. This is gonna be 0.5. Well, let's also divide 8. Mm, wait a minute. Nah, this I don't know how I can reason through this problem, but it's okay. We're gonna have 8 divided by what? God. 8 minus 12 minus 8 divided by 3. We're gonna get 1.33. Okay, 1.33. Recurring, bro. How do you even put recurring? I think I'm supposed to put dash dash. Whatever. Let's just use that. 1.33. We can just leave it at 1.3. It's fine. 1.3. And the next one is gonna be 12 minus 5 divided by 2. Well, we're gonna get 3.5. 3.5. And the next one is gonna be 12 minus 3. 12 minus 3 divided by 1, which is gonna be 9 still. Okay, 9. And then 0 is gonna be 12 minus 0. Then we're still gonna get 12. Okay, I think this is fine like this, my boys. Now, I don't know how we are gonna solve this problem, but I'm sure we might solve this problem. So, who has taken more time now? 0.3, 1.3, 3.5, 9. God. Ah, this problem has challenged me, bro. Calculate times. Create a way to track the time it takes for each car to reach the target. Target minus position divided by speed. That's what I did. Pair and sort combine the speed and combine position and speed arrays into pairs and sort them based on position in descending order. Oh, wait a minute. So I think I might have gotten this wrong. The speed should be the speed should remain the way it is, but the position will change, right? Let me try to see how we're gonna get that together. Okay. All right. Um, we are saying combine the position and speed arrays into pairs and sort them based on the position in descending order. So we are just going to combine them without any sorting yet, right? Then we shall sort them after the combination, right? So let's leave this the way it is. 8, this is gonna be 0, and then this is gonna be 5, this is gonna be 3. Now, the combined one, we're going to have the combined array before sorting, right? So let's have the combined array is speed and time, right? We're going to have two like this. And then 8 is correct. 8 will be going with 4. And then 5 will be not 5, this is supposed to be 0. 0 will be going with 1. And 5 will be going with 1 as well. And then 3 will be going with 3. Okay. Then now we need to just let me copy this, take this up, and then we need to get the sorted combination, right? So let's try to find the sorted combination. Sorted combination with respect to position. So that means we look at the position and then we carry its on like the entire stuff with it. So we're going to say 5 and 1 will come here. And then 3 and 3 will also come here. And then 0 and 1 will be the last. I think that will make sense. So we're going to have 5, 5 and 1, and 3 and 3, 3 and 3, and then 0 with 1. Yep. So with respect to position, we have now the position and speed. We have the combined array, and then we have the sorted combination. So now let's try to get the time taken. I think that will be the problem statement. Let's look at calculator. Cool. All right, so now let's go back to now multiplying this. We're going to have target minus 10. 10 minus, 12 minus 10 divided by 12 minus 10. 12 minus 10 divided by what? Divided by 2, that's the speed, right? So 12 minus 10 is 2. Divided by the speed 2, we're going to get 1. So the time taken here is going to be 1. Good. And then 12 minus 8 is actually 4. 4 divided by 4 is 1 as well. Now 5 minus 12 is going to be, I think, 7. 12 minus 5, 7 divided by 1, we're going to get 7 as well. So this is going to be 7. And then the next one is going to be, this is 9. 9 divided by 3, we're going to get 3. We're going to get 3. And then 0, these, we're going to get 12. So now, as you can see, we have these definite numbers. We have 1, 1, 7, 9, 3, 2. 12. So with that said, let's go ahead and now continue from here. The stack approach, right? After doing this calculation, finding the time, after finding this time taken, right? Actually, this is supposed to be time taken like this, time taken array. So this is the time taken. I don't know why this array is bulky like this. Okay. So this is the time taken array. It's going to help us to actually get the positions, right? Let me make sure everything is okay. Everything is fine. Everything runs well. Good. Let's continue. So, keep track of how many fleets you have. It read through your sorted cars. Okay. Now the stock approach or linear scan. What's going on here? Uh okay. Sort and pair, we have that. I mean, pair and sort, we have that in place. We've calculated the time to track the time it takes for each car to reach the target. Okay. So now we know that car, the first car and the second car, they take the same time. Whereas the third car takes 7 minutes or 7 seconds, let's say 7 hours. A nine here. The other car here takes 9 hours. This takes 3 hours. But this takes 12 hours. Oh God, this is hard, bro. We need to thread through our sorted cars. Remember, we had the sorted cars somewhere here. Okay. This is a sorted combination. That means we have 10, 8, 5, 3, and 0. Okay. Compare the current car's time to the time of the fleet leader ahead of it. Now, if the current car takes more time than the leader of the fleet in front, it cannot catch up. This means it's the leader of the new fleet. If it takes less or equal time, it just joins the existing fleet. If it takes less or equal time, so we check if the current car takes more time than the leader of the fleet in front of it. Okay, so let's look. Who is the leader at this point? The leader here is the first car. And this is the first car. Okay, so compare the current car's time to the time of the fleet's leader ahead of it. If the current car takes more time than the leader of the fleet in front of it, it cannot catch up. This means it's the leader of the new fleet. So that means here, these nine, I mean, seven is the leader of the new fleet, but two of here is a leader of a new fleet actually, because this will take time to catch up with this. So it's going to be a leader of the new fleet. And then this will be its follower, and then this will be its follower. And then these three will be following this. God, this is hard, bro. This is so hard. Okay, if it takes less or equal time, it joins the existing fleet. You can ignore its time as it's now limited by the slower car in front. It just joins the existing fleet. You can ignore its time as it's now just limited by the slower car in front of it. Okay, so let's see. Position 10, speed 2, time is 0, 1. And then this is 1. Catch up, same fleet. Oh, so they catch up when they're equal, right? If it's equal, if it takes less or equal time, it just joins the existing fleet. Less or equal time, it joins the same fleet. And then 7 is slower. This becomes the lead of the new fleet. 3 is gonna catch up to 7. So it will just join the new fleet of 7. Even if it is faster than this car, it cannot overtake it. It will have to slow its speed down and join this fleet. Okay. And then this 12 here is slower than 3. So this is going to create its own new fleet again. All right. Now that is what I understand now. So we have 117,312. I think that's the same thing we have here. 117. Wait, 117. I thought we had 9 or something, right? Am I tripping? 10, 8, 5, 3, 0. What's good, man? How are you doing, bro? How's life? If any, my brother. How's Niger, man? Bro, we've been going back to back with examinations, man. My brain wants to just poof. Bro, uni is not easy, bro. Uni is not easy, especially when you have like unnecessary subjects you have to account for, bro. Yeah, I'm just trying to become consistent again, you know? Because bro, as soon as you are knocked off your pivot, it's hard to get up again, bro. I swear to God. So I'm just trying to find a reason to be consistent again. You feel what I'm saying? Oh, you are done with your uni, bro. I feel like that's the greatest thing ever, bro. Uni is super, super exhausting, man. Super exhausting. 10 minus 12 is 1. Divided by 2 is 1. 1. 12 divided by 1 is 7. 3. 9. Yep. So we don't have any other 3 again. Why are we having 9 from? This is 7. And this is would be 3. 3 minus this is 9. 9 divided by 3 is 3. So we don't need 9 again. Yeah. Okay. Mm. You've been there for real, man. How is like Nigerian system, bro? I feel like education system in Nigeria is super different from ours, bro. Because we have Nigerians here who are saying this country is easier, but to me, I feel like it's just complex, man. Uni at large is super hard. Let's see what else. What else? 10, 2, 8, 4, 5, 3. Okay. Room is getting a little bit hot in here. So that means put this right here. It's crazy over here, bro. Yeah, you're not even lying, broski. You're not even lying, bro. I don't know. I think everything is fine now. So, uh, the total fleets that we've created, we have one. This will be the same fleet. This code up, so they will create one fleet. The next one that will follow is actually slower than this, so it will become the fleet leader. And then the one that will come after it, since it's faster, it will just catch up to the fleet. And then the next one will be slower, so it will become a new leader. So this is a new leader, this is one fleet, and this is one fleet. So that's why there's 3, right? This will form its own fleet. Okay, that makes sense. So data structure, summary of requirements, data structure, you likely want to use a list of pairs or a to-do array for sorting. A stack is very helpful here to keep track of the fleet lead times, but a simple variable tracking the current fleet lead time also works. Precision, ensure your time calculation handles decimals, use floats as integer, whatever. Would you like to try sketching out the logic for sorting and the loop, or should we look why the stack is specifically useful for this type of problem? So I think we can actually get this by first sorting, like what we are doing here, right? Let me see, we can just sort out first. We combine the arrays, right? So we're gonna have 10, 10, 2, 8, 4, this combined array, and then we're gonna get the sorted array. So how do we combine arrays together? Let me find out. How do we combine 2 arrays? I think this is like merge sort problem, right? I don't know. I think this is a merge sort problem. You first merge something and then you sort them. Like Java, so you have 2 arrays like this. Merge will be new int, or we're going to have array1 dot length plus array2 dot length. And then, oh God, what? System dot array copy, array1, 0, merge 0. What is this? What the hell is this? So merge is gonna get stream merge, you're gonna get int stream dot concat stream of array1. and then in stream dot of array two dot to array. I think that's what we're going to try to do. We first merge them, then we'll sort them after, right? So let's try to first merge them. We're gonna get the first position and speed. So we're gonna get int position. We have position array, position array. Okay, position array is equals to what? Position is equals to new array. Should it be new array? Hmm. God, what two arrays like this? How much is equals to this that? Okay, boys, I'm cooked, bro. I'm cooked. Okay, let's say get me the optimal solution. I mean the brute force solution. For some reason, my brain cannot reason well, bro. My brain cannot, I can't reason. Let's see. Hmm. So the simulation of brute force, you need to loop, you run the loop that increments time every time. The update in each step, you update every car's position, new position, because the current position plus speed. Collision check. After moving, you check from right to left, closest to the target first. If car B behind has a position that is greater than or equal to car A ahead, car B's position is reset to car A's position, and car B's speed is changed to match car A's speed. Determination, you stop when all cars have a position greater than or equal to target. The count, you count how many unique positions exist at the target. Um, let's say let's use Java, get the brute force solution. The brute force. And it's many. Let's see. We can enter visuals. Oh my days. To build a brute force approach in Java, we need to simulate the car's behavior by focusing on the arrival times. Even though this is brute force logic, we still need to sort the car by position first, otherwise we wouldn't know which car is blocking which. So I think before we even go to that, we can actually try to do that. Let's first try to sort the stuff. Let's say for int I is equals to 0. Should it be time? We have a speed and position. So merge the two arrays first, then we sort them. God. Okay. Yeah. So int position, n is position dot length. If n is equals to 0, return 0. Then combine and sort O of n log n double cars is equals to new double and 2. Why do you have a quick size of 2? I don't know. For I is equals to 0, I is less than n, increment every time. Cars at I 0 is equals to position I. Cars at I 1. So we'll create a new array that will be their combination just like this, right? Okay. And then we store them within the position I. Cars I in position 1 will be speed. Okay. Just like what we have here. We have 10 at position 0. We have speed at position 1, right? I think it kind of makes sense now. All right. Now sorting by position in descending order. We're gonna get arrays dot sort. We sort the cars array. We're gonna pick A, B, and we're gonna get double dot compare B in position, the first position, and A in the first position. Sort by position in descending order. Okay, so we use the cars and then the positions will be 0 since the position is 0 here. So pick cars and sort A, B, double dot compare B in the first position and A in the first position. Okay, then the brute force comparison. Boolean join fleet is equals to new Boolean with fixed size n. Fleet is 0, okay. Then for int I is equals to 0, I is less than n. If the joined fleet continue, right? Skip if already part of a fleet. This car I is the lead of the new fleet. Okay, fleet increment the count. Where's the count? We started the count by 0. Okay, increment the fleet. Skip if already part of the fleet. Okay. Hmm. This is just complex, bro. Leader time is target minus cars in position 0. Wait. What did we put? This is 1, right? Isn't it the speed? Target minus position, actually. This is the position divided by speed. Okay. Uh, check all cars behind the leader. So J is equals to I increment this J. Join fleet continue. Double follower time. Target minus this. And then, okay, if the follower's natural time is faster or equal to the leader, it hits the leader and joins the fleet. If follower time is less than or equal to leader time, join fleet J is equal to true. Then we return the fleet count. Oh, bro, this brute force is kind of complex. Like, I'm not gonna lie. This is super complex, bro. It's super complex. Okay, so we first begin by getting the actual length. If let me try to code that out to see if I can manage to do it without any issues, right? So the first step, let me break down. The first step, we need to first make sure we have int n is equals to position dot length or position dot length, not dot length like this. And then we're gonna have also int. What else do we need to keep track of? What are we keeping track of, bro? Oh, god damn, we're just checking, bro. We're checking if n is equals to 0, then we just return 0 or return false. Okay, and then now from here we can start combining the arrays now, right? We're gonna get int. I think here is gonna be double, right? Double. That means we are trying to combine two arrays. So we could say combined position, combined array. Combined array is going to be new double. And then we can have this as fixed size n. And then we check if we also need another boolean, I think. Boolean. This is going to be join split new boolean. This is also going to be of size n. Okay. Okay. So the combined array, we need to now look through that um we need to sort actually. Okay. So we need to sort through that position. I mean that is it position and speed? Or we're gonna say for int I is equals to 0, I is less than n, increment I over time. Then we need to say int ooh, cars. Actually, we have this as cars. I think we're calling these cars, right? So this is gonna be cars in position I. I mean, put that to the position, make sure it's the starting element is equals to cars and cars I, right? Well, I think this is the position actually. This is equals to the position. This is the position. And then cars in position I, but this is the second element in that um merged array. We're gonna call this the speed. Uh, that is the speed. Okay. And then what next? Uh, hmm. Oh God, this problem is. Oh, I don't know, bro. Let me just look into this. Why are we even having that stuff there? Here we're just sorting. Double the cars. Okay, and there should be two elements, I think. Fixed size, and this should be two. Okay. Let's remove the join fleet. Be fast match. Okay, the first step. Let's see. Mm, okay, this is the brute force. First step. Mm, combine, combine position and speed. Combine position with speed. That's the first step we need to do. We have double cars, new double fixed size n. We have two, and then for I is equals to 0, I is less than n, I plus plus. Then cars in that position I, in that position 0, then second one. This is fixed size 2, right? It's going to be our speed. I think that is it. What next do we need to do? Let's look at this. Now here we can just sort. Okay, sort by position in descending order. Okay, that's the first thing. The second thing, sort by position in descending order. Good. The next one is going to be, yeah, sorting the position. Our sorting is going to be a little bit simple. Just say arrays just sort. Sure, we're using cars. That's what the key that we're using to sort, and then we're having A. I think it's B minus B and A, or A and B. Yep, I think it's A and B. We're sorting with A and B. Okay. And then in descending order, A and B, we're gonna get double dot descending, is it? Oh, we just compare with the double. Okay, fine. Double dot compare. Wait. Okay, that is it. Double dot compare, we get B. in the first position, O, and then A in that position, first position as well. Wow. Damn. We are down to sorting. That the next thing we're gonna do in descending order, sort by position in descending order. Okay. Brute force comparison. Okay. We need to compare brute force comparison, which will be O of n squared. Combining and sorting is O of n log n. Hello, buddy. Yo, Eddie, what's good, bro? How are you doing? Brute force comparison of n squared. We have Boolean join fleet, new Boolean of fixed size n. We're gonna get fleet count. We initialize the fleet count, and then from I, okay, we're gonna say the fleet count is equal to 0. Here we initialize the fleet count to 0, and then if join fleet in position I, continue, skip if already part of the fleet, and then increment the fleet count. Okay, yep, that's good. And then we have now the leader time. Leader time is equal to target minus cars in position I, that's the entire position, target minus position, divided by target, divided by speed, okay? And then we need to check all cars behind this leader. Then for int j is equal to I plus 1, j is less than n, j plus plus. If join fleet, continue. If it's already part of the fleet, then skip it. And now we need to get the follower time. Okay. And then if the follower's natural time is faster or equal to the leader, it hits the leader and joins the fleet. If follower is less than or equal to the leader, if follower time is less than or equal to the leader time, then join fleet at j is equal to true, or else just return the fleet count. All right, man. Let's try to see now how we are going to solve that. Okay, so the first thing, brute force, we need to combine the position and speed. That's what we did. If the length is 0, we return 0, right? Then we merge the two arrays. We use double since we might get, we might get integers. Cars is equal to new double of fixed size n, but the size, but we're gonna take in 2 items, okay? In the second array, that would be 2 items. Then for int I is equal to 0, I is less than n plus plus. We have position I in the first bracket. We're gonna have it as position, and then cars at I in the second place is going to be the speed. Okay, then we sort it in descending order using the key cars A and B. Then we're going to say double dot compare B at that position and then A at that position. Okay, now we need to do the brute force. This is going to be sorting. Sorting here is what? Sorting here is O of n, O of n log n. Okay, then we need to now brute force the comparison. All right. So we are going to say first int joint fleet. Joint fleet is equal to new. This is going to be a new array, right? New int, actually, not new array. New int of fixed size n, and then a boolean. No, we're going to have int count. Fleet count is equals to 0. Then we say for fleet count is 0. Okay. For int I is equal to 0, I is less than n, then increment I over time. Right. Oh God, this is okay. So if join the fleet, all right, if it's already part of the fleet, join fleet in that position, continue. That means skip it. If you join the position, join the fleet, just continue. Or else, uh, hmm, okay. If we join the fleet, then we need to increment the fleet count. So we get fleet count incremented. All right. What else? What else? What else? Increment that. Hmm, bro. I'm really going through it, bro. Like I feel like I'm not gonna be able to solve this problem. So brute force the comparison. Join fleet fixed size. Instantiate initialize the fleet count to 0. If this has joined the fleet, then skip that. Or else increment the skip it and increment the count. No. How do we increment if it has joined the fleet? Then we just increment the we increment the fleet count after joining. Somebody has joined. All right. We skip and we just join, increment the count. Or else we are now going to look for the follower and leader time. Leader time. I don't know if we should use int or double for the leader time. Is equals to new int. The leader time is actually going to be position target, actually target minus cars in I within the position, within the 0 position. That's going to be the speed. Okay, divided by cars within that, and 1, that's going to be the speed. Okay, int leader time, we get the leader time, and then what next are we gonna do? Okay, then let's look for the second one, which is going to be for int j is equals to where I stopped, and then j should be less than n, j plus plus. Now here we're also going to check again if if it's part of the fleet. If that car is already part of the fleet, we just continue, or else we okay. So now here we also need to get the follow follower time, which is going to be target just like this one, but using j. Cars of j, cars of j. It's going to be the follower time. Now, how are we going to compare the two? We'll compare the two, I think, outside here or within. I don't know. I don't know, bro. Double, actually. I was supposed to use double for that. And we compared within this array. Follow times less than or equal to the leader time. Join leader j is going to be true. Okay. Yeah, we're going to use j. Double. follow time ej. Then we're gonna get if follow time is less than or equal to the leader time. Then the leader, the join fleet at J is gonna be true. I think that is it, right? It's gonna be true. Oh, it's gonna be true. Then we just return the fleet count. All right, not comparison operator. Okay, let's go ahead and return fleet count. We're also going to increment this, right? Increment the fleet count. We need to increment the fleet count. What's going on here? Yeah, we don't have to increment the fleet count. It's less than equal to this. You join this as return the fleet count. Okay. Oh my goodness, bro. What? This is like the most complex thing I've ever done, bro. My whole life, bro. This is super complex. We've even failed. This is supposed to be if join fleet position I continue. Int cannot be converted to Boolean. This is supposed to be Boolean. This is supposed to be Boolean, my boy. Boolean, not int, but Boolean. Okay. Follow time. Okay. This problem, bro. This problem is hard, bro. Code. This problem is hard, bro. This problem is hard. But I think it's not super hard. You just instantiate the positions and you return n is equal to 0, return 0. Okay. Then we'll start sorting and combining. So it's a merge sort, I think. Merge sort. Merge the two arrays. We merge the two arrays. And then we sort it. It's merge sort. Okay. Brute force the comparison. Then Boolean join fleet is true or false. It takes the size of an. If join fleet at position I, then continue. So increment the fleet. Double leader time is target minus cars and I 0 cars I. Okay. For j is equal to I plus plus, j is less than or equal, less than n, j plus plus. If the join fleet at j, continue. Boys, I think we are going to optimize this problem tomorrow, bro. I'm already cooked. I'm so tired, bro. I'll join you guys tomorrow. Let me call it a day, bro. For sure. Damn.